Hi everyone, my name is Jayendra Reddy. I'm a CSC data science student at IRA Hyderabad. In this video, I'm going to explain about probability and statistics. The topic under it is probability mass function, cumulative distributive function. In probability and statistics, the cumulative distribution function CDF of a real valued random variable, say x, which is evaluated at x, is the probability that x takes a value less than or equal to the small x. A random variable is a variable that defines the possible outcome values of an unexpected phenomenon. It is defined for both discrete and random variables. It is also used to specify the distribution of the multivariate random variables. If the random variable is above a particular level, it is known as the Taylor distribution or the complementary cumulative distribution function (CCDF). The cumulative distribution functions CDF of a real valued random variable x evaluated at x is the probability function that x will take a value less than or equal to x. It is used to describe the probability distribution of random variables in a table, and with the help of this data, we can easily create a CDF plot in the Excel sheet. In other words, CDF finds the cumulative probability for the given value. To determine the probability of a random variable, it is used and also to compare the probability between values under certain conditions. For discrete distribution functions, CDF gives the probability values till what we specify, and for continuous distribution functions, it gives the area under the probability density function up to the given value specified. Cumulative distribution function formula. The CDF defined for a discrete random variable and is given as fx of x equals to p of x less than or equal to small x, where x is the probability that takes the value less than or equal to x, and that lies in the semi-closed interval closed a comma b, sorry, open a comma b closed, where a is less than b. Therefore, the probability within the interval is written as p of a less than x less than or equal to b equals to f of fx of b minus fx of a. The CDF defined for a continuous random variable is given as fx of x equals to integration of minus infinity to x fx of t dt. Here x is expressed in terms of integration of its probability density function f of fx. In case if the distribution of the random variable x has the discrete component at value b, p of x equals to b equals to fx of b minus limit x to b minus fx of x. Cumulative distribution function properties. The cumulative distribution function fx of x of a random variable has the following important properties. Every CDF f of fx is non-decreasing and right continuous. Limit x2 minus infinity fx of x equals to 0 and limit x2 plus infinity fx of x equals to 1. For all real numbers a and b with continuous random variable x, then the function fx is equal to the derivative of fx such that fx of b minus fx of a equals to p of a less than x less than or equal to b equals to integration a to b fx of x dx. The most important application of cumulative distribution function is the used in statistical analysis. In statistical analysis, the concept of CDF is used in two ways. Finding the frequency of occurrence of values for the given phenomena using cumulative frequency analysis. To derive some simple statistics properties by using an empirical distribution function that uses a formal direct estimate of CDFs. The probability mass function PMF or frequency function of a discrete random variable x assigns probability to the possible values of the random variable. More specifically, if x1, x2 and so on denote the possible values of a random variable x, then the probability mass function is denoted as p, and we write p of xi equals to p of x equals to xi, that equals to p of s belongs to s, such that x of s equals to xi. Set of outcomes result in x equals to xi. Note that the equation given above is p of xi is shorthand for p of x equals to x, which represents the probability of that event that the random variable x equals to xi. Properties of probability mass functions. Let x be a discrete random variable with possible values denoted x1, x2, and so on. The probability mass function of x denoted p must satisfy the following: sigma xi, p of xi equals to p of x1 plus p of x2, and so on equals to 1, and p of xi is greater than or equal to for all xi. Furthermore, If A is a subset of possible values of x, then the probability that x takes a value is in A is given by P of x belongs to A equals to sigma x I belongs to A into P of xi. Cumulative distribution functions, CDFs. There is one more important functions related to random variables that we define next. This function is again related to the properties of the random variable equaling specific values. It provides a shortcut for calculating many properties at once. Definition. The cumulative distribution function of a random variable x is a function on the real numbers that is noted as f and is given by f of x equals to p of x less than or equal to x for any x belongs to R, that is real numbers. For example, given the probability distribution for RVX, find the cumulative distribution and find P of x less than or equal to 4.5, P, P of x greater than 4.5, and P of 1.5 less than x less than or equal to 4.5. Now take x as 1, 2, 3, 4, 1, 2, 4, 6, and f of x as 0 0.2, 0 0.5, 0 0.1, 0 0.2 as given in the table. We know that f of x equals to P of x less than or equal to x. So suppose x equals to 1.5, then f of 1.5 equals to p of x less than or equal to 1.5. Suppose x equals to 2, f of x equals to, sorry, f of 2.1 2 equals to p of x less than or equal to 2. F of 1.5 equals to p of x equals to 2 equals to 0.2. F of 2 comma 1 equals to p of x equals to 1 plus p of x equals to 2. That equals to 0.2 plus 0.5, 0.7. P of x less than or equal to 45 equals to f of 4.5 equals to 0.8. P of x greater than 4.5 equals to 1 minus p of x less than or equal to 4.5. 1 minus 0.8 equals 0.2. And finally, p of 1.5 less than x less than or equal to 4.5 equals to f of 4.5 minus f of 1.5. That is 0.8 minus 0.2 equals to 0.6. So here is the graphical representation of the values. Cumulative distribution function. The cumulative distribution function of a continuous random variable is f of a equals to p of x less than or equal to a, that equals to lower limit to a integration f of x dx, where f of x is the probability density function of x. P of a less than or equal to x less than or equal to b equals to p of a less than x less than b equals to integration a to b f of x dx, that is f of b minus f of a. Here is another example. The probability mass function example is given below. Question: let x be a random variable and p of x equals to x is the PMF given by. Determine the value of k, find the probability p of x less than or equal to x, p of 3 less than x less than or equal to x. So here is the table given p of x equals to x values and x values. We know that sigma x, p of x equals to 1. Therefore 0 plus k plus 2k plus 3k 3k sorry 2k plus 3k plus k square plus 2k square plus 7k square plus k equal that equals to 1. Now by solving this we get k into values. K equals to 1 by 10 and k equals to minus 1. K is equals to minus 1 is not possible because the probability value ranges from 0 to 1. Hence the value of k is 1 by 10. Now p of x less than or equal to 6. P of less than or equal to 6 means 1 minus p of x greater than 6. That is 7k square plus k. 1 minus 7k square plus k. We know the k value, substitute in it. So we get 83 by 100. Therefore, p of x less than or equal to x equals to 83 by 100. Now p of 3 less than x less than or equal to 6. P less than or 3. So it lies between 3 and 6. That is 4, 5 and 6. So p of x equals to 4, p of x equals to 5, p of x equals to 6. We should add these 3. So we get the final answer as 33 by 100. Thank you.